in mind, they're run by people. And, the goal of those journals ultimately is to publish papers that are true, but that get people to read them. The more subscriptions, the more they sell, right? So I have a good friend who's is a senior editor at a journal. There's really only 3 top-tier journals: Nature, Cell, and Science. He said and I asked him once, I said, what determines whether or not one paper is accepted or not? And he said, well, we get to determine, obviously the reviewers have to give it thumbs up at some point, but we get to determine the direction that the journal wants to go. So during the pandemic, there was an enormous incentive for publishing papers in these journals that provided some either hope or fear or whatever it was exciting at the time, because people were buying up these journals like crazy. I mean, they have to pay their staff too. So it's a business like anything else. Mm-hmm. Unfortunately, there is, aside from the federal research budget, which is frankly, we have a much greater budget than in other countries for research relative to the total amount available, but it's still very low compared to what we need. But money is what drives research. I mean, it's not going to – the more money you have, the more margin for error you can have in terms of the people in your lab. Like if you only have $1 million a year operating budget, like it's a business. You can have 2 or 3 really good people, and if someone's not so good, that's bad. If you have a giant budget, you can have 20 people and 10 of them can suck. That's rare to see that. Usually it's a mixture of competent to talented, the occasional bad apple. And those bad apples are very, very dangerous. And the bad apples I'm talking about are not the kind of people that necessarily go around creating data out of nowhere. These are the people who slice off and make experiments that didn't work kind of disappear. Oh, there was something wrong with that mouse. That is a serious problem in science, far more than fabrication of data.
And how often does that occur?
Oh, it's incalculable, but I would say that kind of – I've been in laboratories big and small across my career. I've been around them a lot. Everyone in every field knows the papers that are like, yeah, nobody believes that.
And these papers are influenced by money? Generally?
So not directly. So the PIs, the lab, this is the way it works. The lab heads, to get to a position where you're running a laboratory at a major university or any university, frankly, you have to love what you're doing. I mean, you don't make a lot of money as a university professor. Mm-hmm. There are incentives through things like companies, and a lot of professors now have companies, and we can talk about that, and that's complicated sometimes or not complicated. But the point is that heads of labs want to make fundamental discoveries. They want to be true. The 3 biggest fears for a real scientist are to get something wrong and to get it wrong for the wrong reasons. The wrong reasons would be someone comes to your laboratory and sees an opportunity to please the PI. This is, I think, one of the major sources of error in science. Publishing papers as a postdoc is what gets you a job. So I've known over the years postdocs, and there's a lot of discussion about this is inside ball of science, where someone gets there and realizes that the head of this lab has a pet hypothesis that's really exciting to them. Why is it exciting? Because it's exciting. They like the idea, but also it would allow them to renew their funding. Yes, definitely, money's involved. And then that person goes and does experiments and shows the PI the experiments that work and doesn't show them the experiments that don't work. And then tells themselves those experiments didn't work because, the centrifuge was off or the mouse was sick or something. Gives themselves reasons why it was okay to remove data. That occurs, I think, I'm going to guess here. I don't know. But based on my observation, that's probably about 10 to 15% of the top tier published papers, I think, don't last, meaning in the years following, they don't replicate and they go nowhere. And I don't think it's because people made up data, quote unquote. I think it's because they threw out bad data or they threw out data that didn't fit their hypothesis and labeled it no good. That is very common. Now, people who, quote unquote, fudge data, make up data, I would say that's 2%.
But that's the Alzheimer's study.
Okay, so the Alzheimer's stuff was legitimately a data fraud issue.
Which is really crazy.
It
lasted for so long before people discovered it.
So then you say, why could that happen? Because
Could you explain to people what happened?
Yeah, so basically the theory of Alzheimer's that's still very prominent is that it's the accumulation of these things called plaques and tangles, which you can see under the microscope, and they've always been considered a signature that you can see with your eyes of neurodegeneration that's associated with Alzheimer's dementia. And it's been the way that people have measured whether or not a treatment has worked or not worked is whether or not it could decrease these plaques and tangles in mouse tissue and sometimes in human tissue. Now, we have to be clear that plaques and tangles do accumulate in the brains of people with Alzheimer's and mice that have mutations that make them kind of like good models for Alzheimer's. But early on in the research on Alzheimer's, so dating back well over a decade now, there was basically a data fraud, fudging of data, we call it, where someone essentially said that there was a label for a particular plaque or tangle protein that represented something that it didn't. And then what this has cascaded into over many, many years is an entire set of theories about which drugs ought to be beneficial for the treatment of Alzheimer's. And I would say now trillions of dollars put into research along those particular lines of inquiry. So what we're basically saying is one mistake can cascade into a series of thousands or tens of thousands of mistakes that can take a field really far astray. And that's what's happened now. They realized that there was a problem with the early data. Now, the thing that's kind of baffling is how the field continued down this path for so long without actually considering alternative hypotheses with any seriousness. Why somebody didn't say, hey, let's go back and test the initial premise of all of this. And part of that has to do with if, biotech is neither good nor bad nor evil nor anything. It's just, but it's a business. And there's a pretty quick runway from a big landmark discovery to a couple of verifications to people founding companies to big dollars coming in through investments.
Yes.
And then, how many times have we been told blockbuster finding in mice and then people with Alzheimer's say, well, when is there going to be treatment? 10 years. How long? About 10 years. This 10 years thing has been kicked down the road about for 50 years. I've been in the research game 30 years, close to it, and so many things have just been kicked down the road. Now, there are kind of maverick folks within science who test very alternative hypotheses. And they are really the heroes of science, in my opinion, because they're saying that's all fine and good, or maybe it's all false. I don't know. I'm going to go a different direction and explore. But in the sociology of science and science funding, it is very, very hard to impossible to get funding from the federal government to do truly high-risk pioneering science. You might say, how could that be? In general, when you get funded by the government, my lab's been funded by the government for many years, you get funded for work that is already completed. You show it to them in a grant. You say, this is what I want to do. You get the money, and wow, the paper comes out the same year. How did that happen? And then you use the money to fund the next thing.